Hi guys, for this next video I will discuss how to solve the equivalent resistance of a given circuit. Let's begin with two series connected resistors R1 and R2, with values 8 and 4 ohms. The equivalent resistance of resistors connected in series is simply the sum of the individual resistances. So the equivalent resistance of the two series connected resistors is simply R1 plus R2, which is 8 plus 4. That will be 12 ohms. Another example is two parallel resistors with equal value of 20 ohms. The equivalent resistance of the two 20 ohms in parallel will be 10 ohms. Guys, to solve the equivalent resistance of parallel resistors, it is simply add the reciprocals of the individual resistances, then take the inverse of the sum to get equivalent resistance. In this case we can use the formula 1 over R1 plus 1 over R2. Or we can simply write 1 over R1 plus 1 over R2 raised to negative 1. If we are going to substitute the values, 1 over 20 plus 1 over 20 raised to negative 1, it's gonna be 2 over 20. Since it is raised to negative, it will be 20 over 2. And the answer is 10 ohms. Remember guys, that when n number of resistors with the same resistance value are connected in parallel, the equivalent resistance is equal to the value of individual resistance divided by the n number of resistors. In this case we have only two identical resistances. The formula will be R divided by 2. Or it is simply half of the value of the resistor. In case that we have three parallel resistors with the same value, the formula will be R divided by 3. Next example guys is three parallel resistors with three different values. Okay, to solve for this we are going to use this formula. 1 over R1 plus 1 over R2 plus 1 over R3 raised to negative 1. Plugging in the values, 1 over 8 plus 1 over 16 plus 1 over 32, raised to negative 1. This will be 7 over 32 raised to negative 1. Or 32 over 7. And this will be equal to 4.57 ohms. Remember guys that the equivalent resistance in a parallel circuit will have a lower value than the smallest value of the resistor in the circuit. Just like this example 4.57 is less than R1, 8 ohms. Next example is a 4 ohm resistor in series connected with 10 ohm and 5 ohm resistors in parallel. In solving the combination circuit, we will check the circuit if what components first are we going to solve. In this case, we are going to simplify the parallel circuit. So to find the equivalent resistance of 10 in parallel with 5, that will be 1 over 10 plus 1 over 5 raised to negative 1. Simplifying, 3 over 10 raised to negative 1. To remove the negative exponent, it will be reciprocated 10 over 3, which is equal to 3.33 ohms. Then it will be added to 4 ohms. So the equivalent resistance of this circuit is 7.33 ohms. Next is a 10 ohm resistor in parallel with 2 series connected resistors, 6 ohms and 2 ohms. In this case, we are going to simplify first the series resistors. So simply add 6 plus 2, which is equivalent to 8 ohms. Then the result will be in parallel with 10 ohms. 1 over 10, plus 1 over 8, raised to negative 1. This will be simplified to 9 over 40 raised to negative 1. To remove the negative exponent, then it will be written as 40 over 9, which will be equal to 4.44 ohms. Another example. To solve this, first we are going to solve the portion of parallel resistors. As we know these two will be equal to 10 ohms. We will redraw the circuit like this. Again guys, if we have two identical resistances in parallel, the answer is simply half of the value of the resistor. Again, this will be equal to 5 ohms. So, the equivalent circuit will be like this. It is now simplified to a simple series circuit. This will result in 55 ohms. Next circuit. Two 10 ohm resistors connected in series and its equivalent resistance is in parallel with a 20 ohm resistor. To solve this problem, we will add first the series resistors. We have 10 plus 10, which is equal to 20 ohms. Now it is simply 20 ohms in parallel with 20 ohms. Since the resistances are equal, then it will be equal to half of the value of resistances, which is 10 ohms. So the equivalent resistance will be equal to 10 ohms. Another circuit. It is a combination circuit with 3 series connected resistors in parallel with 1 resistor. Then its equivalent circuit is in series with 2 other resistors. First thing to do is to add these 3 resistors in series. So 10 plus 5 plus 25 will be 40 ohms. Then the equivalent circuit will be like this. Now, we will solve the two 40 ohm resistors in parallel. We already know that 2 resistors in parallel with the same value will be equal to half of the value of resistance, which is 20 ohms. So now it is simplified to a simple series circuit. The equivalent resistance will be equal to 10 plus 20 plus 25, which will be equal to 55 ohms. Okay, let's have a complex circuit. This circuit consists of 2 series connected resistors which is in parallel with 2 resistors. And their equivalent resistance is in series with 3 resistors. Initially, we are going to add 11 and 9, which is equal to 20 ohms. Now we will redraw the circuit. Next step is to add this equivalent resistance 20 and this 20 ohms in parallel, which is equal to 10 ohms. It can now be simplified like this. "10 in parallel with 10 will be equal to 5 ohms. The circuit now is a simplified series circuit. 2 plus 6 plus 5 plus 8. So the equivalent resistance is equal to 21 ohms. Okay, the next example is more complex. It is a combination circuit. In this example, the value of 10 and 20 ohms were frequently used, so that we can solve the circuit simply using the method we use in earlier part. To solve the given circuit, we will start from the right portion. Initially, we will add 10 plus 10. It is equal to 20 ohms. This 20 ohms will be in parallel with 20 ohms. So 20 in parallel with 20. It will be equal to 10 ohms. Next is to add 10 ohms with this 10 ohms. And this will be 20 ohms. This 20 ohms now will be again in parallel with another 20 ohms. 20 ohms in parallel with 20 ohms. This will be 10 ohms. Then this 10 ohms is in series with another 10 ohms. Again, this is equal to 20 ohms. "20 ohms now is in parallel with this 20 ohms. So definitely, it is equal to 10 ohms. Now 10 ohms is in series with 10 ohms, which will be 20 ohms. Then again 20 ohms in parallel with 20 ohms. This will be equal to 10 ohms. This 10 ohms now is in series with two resistors which are 5 ohms each. So adding these three will be equal to 20 ohms. 20 ohms in parallel with this 20 ohms. So the equivalent resistance is equal to 10 ohms. So that's it, guys. That's how we solve the equivalent resistance of series, parallel, and combination circuits. Hope you enjoy this video.